Hi, this is Ali, and I'm going to show you a demo of some commands that you could use to do some pre-processing in Python using pandas. So what I've done here is that I have started Jupyter um, Lab. So Jupyter Lab is actually installed with Anaconda package. So Anaconda is a package that you could download, and then when you run it, you could either run Anaconda Navigator or you could just run the Anaconda prompt and type in Jupyter Lab. So it starts the Jupyter Lab here. This is the server. I prefer this one because it's you have more control. You know what's going on here, and if there are any errors, you can see. So once you run this, it allows you to like open it to a browser. So it automatically runs it. If it didn't, just copy paste this part and just put it in the browser. So when you first come here, it looks like somehow this. You could start a Python 3 notebook, or like it could change depending on the installation, but you can create a text file or run a terminal. I'm going to start with a text file, and I'm going to show you how to create a CSV file from scratch. So, I'm going to use some data here, and a CSV file, a comma separated values file, is nothing more than a file that is a file in which the data is separated by a column. So first I start creating the column. So the first column, I call it X, and I add a comma, and then I press Y. So this is my header, and now I can have more data here. Let me make this a little bit bigger. Next, what I have here is, I don't know, like I could add some numbers like 10 and 15, 12 and 20, and so on. I could just add anything here because I'm just creating some random file. So once you have enough data, then you could basically save this file. So I click on File and Save. So this file is saved here as untitled1, but you could just right click and rename it as, I call it data pairs, like it's a pair of data. And instead of txt, I save it as CSV. So when I save it as CSV, if I now double click on it, it understands that it's a CSV file, and it opens it in this kind of like format. So you have, it shows you the 6 rows and the top 2 columns. Now let's see how we can create a notebook and actually load this file into our like our notebook. So I could click on this plus again. Now this time I choose a Jupyter notebook. So this is a notebook that is created. I could go ahead and rename it right now to something called Preprocessing, I don't know, prayers. And this is the file that I have. Now I could just close this file. I've got some other copies here, but this is all I have right now. So this is the file. I could just move it around, and that's what I have. So in this file, you can have 3 types of data. You can have a code or markdown, like to document what you have, and also a raw file. So it's better to start with the markdown, and markdown is basically a format that you could use different headings or add images. It's very simple to write. It's a text file that is rendered beautifully. So I say, okay, Python, and I can have another level, pandas and numpy, and I could just add some information like about Python, or yeah, you could have like pandas is a library for data pre-processing, etc. And when I press Control and Enter, then it beautifully renders it for me, and I've got a nice kind of formatted image here with different headings and so on. So I can add another cell, so these cells that goes below it, and now I can have a code and start writing code. I could say print hello world, and when I press Control and Enter, it just prints it for me. And I can have multiple cells, different cells of code here, which is going to be really useful. Now what I want to do is I want to start reading that file. To start using pandas, you could import pandas library, import pandas, and you put an alias as PD. That's PD is usually the alias that everyone uses. And also I want to import matplotlib.pyplot as PLT. So this is going to be the actually the library that we use for visualization. So when I press Control and Enter, it takes some time. It shows that it is kind of trying to render it, try to import it, and the CPU is working hard right now. And once it's done importing it, then we're good to go. Okay. So now what we want to do, before we continue, I want to quickly double check the performance settings here, and because yeah, we had some kind of performance lapse, that's fine. Okay, so yeah, this is the third time I'm recording this actually, and within the past few hours, and like sometimes the video recording does not work as well as it should be. Okay, fingers crossed this time is going to be very well done. So now I'm going to here continue try to read the file that we just created. So I could say pandas that when I press the tab, PD dot, when I press the tab, it shows me some of the options that I have. So I want to read a CSV file. So I say read CSV. I give the file the name of the file. So it was data pairs.csv, if I am not wrong. Yeah. So this is the data that I just created. This is a file, and it shows me the content of that data. I can press B and it creates another cell for me, and I could start processing the data. Right now, this data is not stored anywhere. So I store it in a data frame, which is, I start with the df and I say data frame pairs equals to that. Now this time it doesn't show me the data because now the data is stored in df pairs. What I want to do now is that I want to take a look at the data, and this time I use head. Head shows me the first 5 rows of the data. Also, I could say describe, and describe, sorry, oh, I said pairs. Okay, pairs. So describe basically gives me the some statistical summary of this data. So count how many x and y's we have, what are the mean of them, the standard deviation, minimum and the maximum, and the different quartiles. So I could continue like exploring this more, and I say data frame pairs. Now what I can do here is that I can check to see if we have any missing values. To do that, I say I print is NA. NA means not a number or not anything, and when I do that, it tells me that, well, all the values are already there. We don't have any missing values. So why not go and try to add some missing values here? What I do is I just try to, in my file, I try to add some other numbers like I don't know, 41. I add them as pairs. But I could just leave some of the pairs like empty, like that. So if I add, if I remove some values here, like I remove that, I remove a bunch of values from here, okay? I save this file and I go back to this preprocessing pairs. Now I have to come back and read this file again. So when I read that file and now I take a look at the head, I'll see that we have actually some missing values. When I click on describe, well, the describe changes a little bit because of the number of missing values. But now when I say, tell me if we have any NAs, it tells me that, yeah, we have like 3 of the X's and 3 of the Y's are actually missing here. So now what we want to do, we want to fix this missing value problem. So this missing value kind of problem can be fixed by many ways. First, what I can do is I can try to drop those missing values. So I could say df pairs. So df stands for data frame. So I could say df pairs dot drop na. So when I do that, I'll see that it removes those missing values, anything that we have there which is not a number, and gives me just 2 rows here. So these 2 rows are basically what is left, and we have removed a lot of data. So from, if I want to print the whole data again, by the way, this doesn't remove it from our original data frame. It just returns it. So I could put it in another data frame. I could say data frame pairs NAs NA dropped, something like that. So when I do that, it doesn't print it for me anymore. I could just add 2 lines of code and I say, okay, just print it for me. And it now shows me that one, so that the result of that is displayed there. So, but as you can see, it's removing a lot of data, and I may not want that, right? So instead, what we can do is that we could use other ways to fill the missing data. One way to do that is to basically try to add a specific value to our data frame. So I could say df pairs dot fill NA. So fill the NA now, not the number values, and I could fill it, for example, with 0. So if I fill it with 0, you'll see that all the missing values are now 0. I could say 1, or I could, for example, use the mean of each column. So I could say data frame pairs dot mean. So it calculates the mean on each column and replaces the missing values with that mean. So here, let me go up first. When I say data frame pairs describe, it tells me that the mean of the X column is 23.8, and for Y it's 31.8. And you can see here that when I say fill the missing values with the mean of each column, it put 23.8 for each of the missing values in the X column and 31.8 for the Y column. You could also, there are some other ways that you could do that. You could say data frame pairs, I really want to go to Paris, I guess. So div pairs, fill NA, and I could use some other method. I could say there are some methods. One of them is pad. Pad just replaces the numbers with the previous value that is available. So if you take a look at here, all those missing values on the X column is filled with 10 because 10 was the previous value. And here, the last three missing values here are filled with 67 because that's the last value that was seen. After that, like other than pad, what we can use is bfill. This is the opposite way of pad. Pad is kind of a forward fill. You could actually put ffill as well. But backfill will replace the values with the value that is at the other side. So here we have 10, but all the other missing values are filled with 34 because 34 was a value and they were returned back. Because we didn't have any number at the end to backfill, then all these three inans remain the same. So these are some of the methods that you could actually use. One interesting, like all these methods have some like good, like pros and cons, and there is another way that you could do that. You could say interpolate. So when you say interpolate, what happens is that the pandas is trying to guess the values that are between two numbers in a linear fashion, and you can see that like I had 10 here, and then everything in between was missing up until 34. So it tried to guess that, well, if my first number is 10 and the next number is 34 and I have three values between them, what would be the actual value of them? So it interpolates that data and then puts 16, 22, and 28. So there is the difference is 24, and there are three numbers. So there are three. The difference by adding the difference of 6 to each number, it actually creates the other numbers. For the 67, it doesn't do anything much. But I wish it could just increase it, but it just because there is any other number at the end, it assumes that it remains the same. So this is another method that you could use, interpolate. And now that we have that, there's something else that we could use. So we could try to get access to, I don't know, let me see if it works or not. So yeah, so something else you could do is you could actually try to plot the histogram of a certain column. So I just say df pairs x.histogram, and shows me the histogram. You could add the title to to this diagram and just show it again, which also works. So if I want to get the histogram of y, then it helps me here as well. So if I do this interpolation and then I put it here instead, then you see I've got more 67 values here for the y, and if I press X, I see that, well, I've got some values in between. So basically, you learned here that when you take a look at the data, there are many things that you could do. You could fill the missing values. If you have two different data sets, you could just import them, put them into different data frames, and you could say like data frame pairs dot join. So this join enables you to basically join two different data frames, tables based on a common value, and create a bigger data set. You could sort your data frame by a specific value. You could get different pairs. You could create series. So there are a lot that you could do. And basically everything will be stored here in this notebook. And if I close this notebook, okay, and come here and open it again, the beautiful thing about notebooks is that not only you get all the code, but you also get the the output of each command, or if you have multiple commands, you get the output of them, which is beautiful because you don't need to run everything. You can tell a story here. You could say, well, I did that, and I did all these different methods, and I ended up in this data set that I created at the end. And feel pretty free to add different, I don't know, comments, like using like documentations here. You could just, at any point, you could say, well, now we are done exploring the data set, for example, something like that. Then it just adds it beautifully at the end. So that's it for now. I had, let me see if there is something else that I have that I could show you. Yeah, this is basically something else that I just did. And the example that I provided to you, that customer churn, it's nothing but basically there's a mortgage fund file. It's a CSV file. It's the same as before. If you take a look at the data, you'll see that, well, this is a CSV file that has all these different columns, but there are a lot of different rows here. I close this. Now let me check the stats. Yeah, still doing good, I guess. Yeah. And so one more thing, this is the example that I provided to you. So when you say import, like this is the example that I covered in the scenario that we had. So this is exactly what I did. Like I imported pandas, matplots, I read the file and put in the mortgage, and I displayed it, and I described it. So these are all the information that we have. Then we have histogram, like we just drew the histogram of this one. So there is the title, I could say PLT, matplot, the title, and then add a beautiful title to it. Then plt.show will show that to you. And kernel density estimation is basically is going to give you the an estimation of the density, or the plot the distribution of your data, which is great. And as you can see here, the data is skewed to the right. So what I did here is that I tried to get the log of the mortgage. So here I used NumPy. So NumPy is the other library that you could use. And so in this line, what I did was that I said mortgage, the data frame, create a new column called amount _ log, and get the values from the log of the column mortgage amount. So I did that, and then in order to get the KDE, which is the kernel density estimation, I had to remove the any infinite numbers, because like when you get the log, there's some infinite numbers could be generated, which you cannot use to get a kernel density estimation. And here what I did was that I said, well, get that series and only give me the ones. So this is kind of a filter. You could filter by adding a condition here. Give me all the rows that has a finite amount log amount. So if the amount log is finite, then like give me that number. And from those, like if there's any NA, well, there are some of them could be still NA. Drop them, plot it, and plot the KD, kernel density estimation. Just showed me this one, which looks a little bit better, but it's still not great. So I tried the same thing with a square root, and it seems like the square root gives us a better normal distribution. And this is going to be kind of something that we might end up using. If you want to compare two different variables, you could use a scatter plot. This was one exam question, basically, that if you have two variables, what is a good what is a possible good plot for it to compare them. So scatter plot is a good one. There's also the Verdis map if you want to use a good map there. So this is the Verdis color map. But when you look at these, although you could see you could compare different things, but they're not looking great because we have a lot of values. So when you have a lot of values and a lot of points, sample points, what you could do instead of scatter plot is a hex bin plot. So in hex bin plots, it's just simple. I say mortgage plot the hex bin on the x is the rate and compare it to the competitor rate. So these are the two columns that I'm comparing, and I could put a grid size. So what you can see here is that I've got the rate versus competitor rate, and each of these hex plot, they actually contain thousands of sample points, but it's not it's not very crowded here because like we put a lot of them into these single hex shapes here, and as you can see, now I can take a better look and I say, well, it seems like when our rate was around, most of the times when our rate was around 2, the competitor had a lower than 2 rate, and probably that's why that we didn't have a lot of funded applications. So this is basically what you could use. So if there's also another library called Seaborn. So Seaborn is similar to Matplotlib, and for a count plot, regular, maybe a bar plot, I used Seaborn and got the number of funded applications. And you could see we didn't have a lot of funded application, like maybe around less than half of our data was funded. And you could see here why. You could see that, well, because the rate that we provided was less than the competitor rate at most of the cases, then that's why we've got this low funded rate. You could also use a box plot, and the box plot is going to give you a very good overall view of each variable. And so there are some whiskers here. So this is the overall main distribution of a specific kind of data or different samples that you have. And whatever that is, any data that is located outside of these box plots, that's an outlier. So if you remember, we had a lot of, like for the amount, we had a lot of big values. So all these big values that we had like caused the distribution to be skewed to the right, and they now show themselves as outliers. So the mortgage amount, we may have some mansions or big homes somewhere that they require very big mortgage rate, mortgage amount, but they are not the average case. So the average is around here, and then we have some distribution that goes that way, but we have also a lot of outliers. If I'm not wrong, that is outlier if it is outside the 90% of the data, and so these are the cases. So now, when we compare the square root of the amount and the amount itself, we will see that you can see here that we reduced the number of outliers and we created more even distribution. So it's clearly visible in this box plot, and we could just compare these two, that now with this different kind of transformation, we can have a better distribution that could be compared with maybe rate and competitor rate. Maybe you could do something for the competitor rate as well, or remove some outliers or things like that, but the rate looks perfect. So we want everything to look like that. So we could also use histograms and show the histograms for different data that we have. This is a scatter matrix. So a scatter matrix is used to compare more than two variables. Usually, like we've got the rate competitor here, we have four variables and four variables here. And so we've got rate, competitor rate, amount, and risk score, and rate, competitor rate, amount, and risk score. So in a scatter matrix, the risk score and risk score, if you're comparing the same variables, it shows the histogram. If not, it shows the scatter plot. That's why the all these center kind of boxes here, they're all histograms. So that is also the tool that you could use. And then here after that, we are going to, when our data is ready, we had done some exploration, we used some visualization, the pre-processing is done, then we can go ahead and take a look at what is available here for basically creating a model and like training a system to get the result that we need. So so that's it for now, and I may cover some of these different points at a later time when we talked about data pre-processing. Okay, thank you.